Hi everyone, welcome to the Forensic Chemistry Lab. In this video, my goal is to go over some of the basics of the course, but this is in no way meant to substitute the first day of class. It's instead just designed to give you a place where you could review some of this information, at any time, in any place, that kind of thing. So basically what I want to do is I want to briefly cover safety. You're supposed to have had at least the general chemistry lab now, so you're already probably familiar with some of the safety protocols, but I do want to briefly review that very quickly. Then after the safety, which of course is very important, and the only reason I'm going over it very quickly is because you'll spend more time on it during your lab course, I want to talk a little bit about the lab report and a little bit about the resources that are available. Now, if you're watching this video the first semester that the video is offered, our plan is to make a video for each and every experiment. However, they're not made yet, so I can't promise that they will be there, but that is the goal, to make it, a video for each experiment, to go over some of the concepts and whatnot for each of the experiments. So basically, what I want to do is go through the lab reports, and then subsequent videos will go over the specific details of the theory of the experiment that you're doing, as well as the practical stuff that you have to do. As you move on in your chemistry courses, it becomes more and more important that you not only understand what to do, but why you're doing it and what it means and what conclusions can be drawn from this. And this is especially important if you're interested in working in a forensics lab, because although there may be many routine samples to run, at times you're going to have samples that are not routine and are not straightforward. So therefore, it's very important that you have a basic understanding of these concepts, so that if you get a sample that you've never seen before, you have a way to analyze that sample. So let me get into it. And again, I said I'm going to briefly go over safety, even though safety is super important. I'm only going to briefly go over it because you're going to go over it more in lab. So once the labs start, they're not going to start the first day. The first day will be like an introduction to the course. But once you start the labs, you need to make sure you have completely covered legs and feet. Okay, make sure you're wearing a lab coat, gloves, and goggles. You can't bring any food or drink in the lab. And if you're using the hood, please make sure that you put things back organized. We don't have enough hood space in the forensics lab, and there are multiple classes in there. So it's really important that it doesn't get, overwhelmed. Also, you're expected to keep a lab notebook and comprehensive notes of your observations during this course. And that's basically that. Make sure that you are following all waste protocols, and we're not putting anything toxic or nasty down the drains. Also, just use general common sense. If you spill something, clean it up. If you spill something on yourself, you get it off of yourself as quickly as possible. And finally, you're aware of the dangers and the toxicity of the chemicals that you're using in the lab. Sometimes we're using things like salt water, which are relatively non-toxic, of course. I guess unless you drink a bunch of it, it's relatively non-toxic. However, at other times we're using concentrated acids or concentrated bases, which are much more of an acute hazard. We're also using a lot of flammable materials and things like that. So it's important that you know which is which and that you have an idea of what to do. Part of your pre-lab assignment will be to write the chemical hazards and wastes of the things you're using in the lab. This is designed to force you to look into these details so that you're familiar with them before you go. So that's enough about safety for this video. The next thing I want to talk about is the lab teams. So you are going to work in partners in this lab. If there's an odd number of students, there may be a group of 3, but you can expect to work in partners. So you are going to share data, but you can't copy each other's lab reports. So make sure that you're turning in an individual lab report for each team member. And when we say individual, not only should it be individual in that it has your name on it and not your lab partner's name on it, but it should be individual in the sense that the verbiage should not be exactly the same. We are fully aware that you're writing about the same concepts, so there will be similarities, but the sentences should not be the same. They shouldn't be different by a comma or a plural versus a singular or things like this. Writing things in your own words is a skill. It's a very important skill that each of you develop, and as you do it more and more and more, it becomes easier and easier and easier. At first, it can be kind of a pain to read something and then try to write it in your own words without using the words others used. Eventually, it just becomes second nature and very easy to do. So practice is the best thing. So I want to talk a little bit about the lab reports. And the lab reports that I'm going to talk about in this video are very generic things. But we will also talk about the lab reports in the individual videos where there are specific details, for example, if we're doing thin layer chromatography, specific details to the thin layer chromatography experiment that you should include in your lab reports. Now, what we're not going to do is like help you write your hypothesis, like we did in Gen Chem if you took Gen Chem here, or things like that. But as you watch the videos on the individual experiments, you will find much of, if not all of, the information you need to complete your pre-lab. So that's basically that. The first thing you need for your pre-lab is pretty obvious, pretty straightforward, a cover sheet, okay? And that should contain the experiment number, the title of your experiment, your name, the name of your lab partner, the date you completed the experiment, so on and so forth. So just the generic cover sheet type of information. We're not going to be picky on formatting, whether you put a space between these things, whether you put a line between them or whatever, or the size of the font, or whether it's bold for your name or whatever. Use whatever style you want, but make sure that it has that basic information as a cover sheet. The next thing you want to have is a brief introduction. And we give you a challenge here that it has to be no more than 300 words. And that maybe seem great. Hey, I can write it in less than 300 words, which is about a page of normal double-spaced text. However, I think what you're going to find is you have the opposite problem. You need way more than 300 words to put in all these concepts. So what you're going to have to learn to do is to write concisely, which again is a skill. Practice makes perfect. So these types of things are going to include an introduction that can include some basic background information, some theoretical information, hypothesis, essentially what you expect to happen when you do these kind of things, the forensic application of the technique that you're using, and what is the purpose of the experiment, what are you trying to accomplish, this kind of stuff. But you want to keep it relatively concise. Definitely make sure that you have a hypothesis in here, and definitely make sure that you go into a little bit of detail about the basic background. Now, this is very generic information, but it will be given in a more specific way, which I'll show you in a minute, in each of the lab experiments in the lab manual, so that you'll have a better idea of what you need to put in for that specific experiment, which again will be addressed in the videos. Then you need an experimental procedure section. So this is just what are you actually going to do to perform the experiment. A good rule of thumb for this is you should make a bulleted list that you could use if the lab manual were taken away from you. So you could do the experiment without the lab manual, just looking at your bulleted list. If you have that much detail, perfect. Okay, that does not mean you need to go into, huge amounts of detail, but it also shouldn't say, perform TLC for the TLC experiment. It should be a little more stepwise than that. And then finally, the chemical hazards section. And that should say hazards instead of hazardous. But this is basically the section where you can write about what you're going to do with the waste, what is potentially toxic, this kind of stuff in the experiment. This should all be completed, must all be completed before you come to lab. And we call this the pre-lab. Note that this will be a few pages, okay? The introduction will be about a page. The experimental procedure will depend on the experiment, but it could be anywhere from 1 or 2 pages, something like that. The chemical hazards, that's going to be basically a paragraph. All right, what are you going to do during the lab? You're going to complete the results section of the experiment. And this is going to be, you may collect a spectra, you may make a picture, you may take a picture of something, you may calculate an RF in the case of TLC, and the lab manual actually has spaces for you to write in some data that you collect during the lab. So this is basically your what you're going to do during the lab. Your experimental procedure should talk about how you're going to fill out all these sections. What exactly do you need to calculate? And so on and so forth. And there also are some questions in the lab manual, and you are going to provide answers to each of those questions. And again, you can do that during the lab. Watching the video and having an understanding of the why will help you with the questions. The questions are not going to be how many milliliters of solvent did you add to the beaker. The questions are going to be more along the lines of how did the polarity of the solvent influence your results. So it's more about why, or more about the understanding the material, than it is about just the practical applications. So we're not going to ask you to memorize details of how many milliliters of solvent you used or things like this. Finally, the completed after lab section, which is the post lab. And this includes your conclusion. So what did your data mean? So you collected some data, then you analyze and interpret that data. And this is, again, uh, expelled out more in more detail because it's specific to each experiment, but you are going to have less than 300 word conclusion. Here you may not have as big of a problem, you know, filling it in 300 words. The introduction is going to be pretty challenging to get it in 300 words. Here it might not be as big of a problem, but it's really important that you interpret your results. Are your results what they expected? If they are, why did you expect them to be that way? If they aren't, why aren't they? So on and so forth. It's really important to interpret data. So in the general chemistry lab here, for example, we synthesize aspirin. And it's not inherently obvious whether the synthesis went well or the synthesis went poorly. But what do? Well, we calculate theoretical yield by measuring the mass of our product. And we measure the melting point of the product. And we use those data points, like we expected to get 2 grams and we got 1.8 grams, and it had a melting point exactly the same as aspirin. We use that information to interpret whether the experiment went well. It's very important that in the conclusion section, you use the information you have available to make your case for whether the experiment went well or the experiment went poorly, or you got what you expected or you didn't, and so on and so forth. So that is very, very important to learn how to interpret results. It is a skill that is acquired through time. So practice makes perfect, like many other things. We do have a supplemental information section where you put any charts, figures, graphs, whatever, that are too big to fit into your regular lab report. We give you a general guideline if they're larger than half a page. So for example, if you do a GC, you print out a chromatogram, it's a full page piece of paper, you can put that in your supplemental information section. And then finally, works cited. You may need to look things up as you're doing this. Be careful that, of you using Wikipedia. It depends on what it is, whether or not it's a credible source, but textbooks tend to be better, scholarly articles tend to be better. The truth of the matter is you're not going to need a whole lot of sources here, because pretty much everything that we're going to go over is from a textbook, right? It exists inside of textbooks, so being able to find information about it is relatively easy. You're not going to have to go find some journal article where one person 10 years ago write about this specific thing. It's not like that. It's very broad topics where you should be able to easily find credible sources. All right, so we do have some report requirements and formatting. So standard format, 12-point font, 1.5 or 2 space, justified, 1-inch margins, this kind of stuff. Okay, again, we're not going to be super picky about this, but use some kind of normal formatting. Don't use some kind of crazy formatting. I guess that's relative, but don't use like a 8-point font that nobody can see, and don't use a 50-point font where you can fit 3 lines on a piece of paper. This kind of stuff. If you stick to this, that works well. All right, make sure you have the cover sheet, the brief introduction, the experimental section, the results section, the answers to questions section, and the conclusion section, and some references if you need it, and the appendix if you need it. All right. This is important. All chemical structures must be created in ChemDraw or ChemSketch. ChemSketch is a free software that you can download to a PC. I'm not positive if it works on a Mac or not, but we are going to want to learn how to draw chemical structures in computer software. This is a skill every chemist must have, and it's a skill that you're going to practice in this course. ChemDraw is quite expensive, so we don't expect you to have that, but ChemSketch, again, is free. You can't hand draw your structures. Okay, and we don't want you to copy or paste images from the internet. You do need to actually draw the structures yourself. This is the same thing, although the learning curve here is fairly quick. Once you've drawn 5 of them, you can draw the 6th one relatively quickly. All right. Please proofread your reports. This is really important, okay? We're not here to be English teachers and correct your grammar and spelling and stuff like that, but proofread your report. Does your sentence make sense, right? Over the years, I've read a number of lab reports, and when I was a student, I wrote a number of lab reports where, for one reason or another, in the middle of a sentence, I changed my thought. And then when I reread the sentence didn't make any sense. So it's really important that if you proofread it, then you're going to find that. Okay. Now we can grade a little bit if your thing is full of, if your lab report is full of sentences that don't make a whole lot of sense, or if it's full of grammatical errors that lead to, you write a paragraph that's one sentence or something like this, and every paragraph is like that. But if you proofread it and you try to focus a little bit on the writing, your writing will improve, and that's good for you. Okay. The lab manual is going to be an excellent source of information, and you can use that for your lab reports, as well as you can cite it if you'd like. You could also use the videos for your lab reports. I don't know that it's necessary to cite them because they're basically from the lab manual, so you could cite the lab manual even if you use the videos. And if you have any questions about your report, come and ask someone. Go ask your TA. You could come ask a staff member. We'd prefer you ask your TA, especially if it's about formatting type things. If it's about content or explaining a concept or something like that, please feel free to ask a staff member because we can give you good guidance on that. But the TA may have some specific formatting likes that they have that we may not be specifically aware of. So just go ahead and do that. So I hope this gives you a little bit of an idea of what is required for your lab report. But basically you have a pre-lab, which you do before class. You fill in your results section where you write down your data during class, and then you analyze your data and maybe provide some supplemental information, which you would collect during the lab in your lab report. Last thing that I want to show you before I end this relatively brief video is from one of the experiments. And this gives you an introduction and conclusion paragraph for a TLC experiment. And it says, write a 300-word introduction before coming to lab. For this experiment, the introduction should focus on TLC. Be sure to include a description of the stationary and mobile phases to be used, including their polarity. Also include the polarity of the molecules you wish to separate. Finally, predict the relative RF of the analytes for a solvent that will separate them. Relative RF values are not exact numbers, but predictions of which compound will have the lowest RF, the next lowest RF, etc. And this is essentially showing that you have an understanding of how TLC works. We can predict, kind of, relative RFs, although RF is in some ways empirical and solvent dependent. We can at least give it a guess as to what might happen. And conclusion, I'm not going to read it, but it's kind of the same thing. That kind of walks you through how these different things are working and what you should include in your conclusion. It is very important that at a minimum you touch on these points, okay? And again, because I said some of this is going to be empirical and you can't really know before you do it exactly what's going to happen, that's totally fine. But you can give a relative idea of what's going on. What is going to be your best source of information of this? The lab manual and the video. Okay, the lab manual and the video can and will cover all of these things and give you a general idea. That being said, we are not going to specifically write these things for you. I'm not going to specifically discuss each of these topics and how I would write it into the introduction. I'm instead going to give you an entire video, which may be 30 minutes, and you're going to need to distill that down to a 300-word introduction. The best advice I can give you is, as you watch the videos, read this before you watch the video, and as you watch the video, take notes on the different things that you say, hey, he said this, and this is going to be important, and so on and so forth. So that could be very helpful for you. So I just wanted to welcome you to the forensic chemistry course. I did want to thank you for watching this video, and I hope you find these videos useful and they help you to be prepared for lab. Again, it's super important to focus on the why. What is the theory? What are we looking at, and why does it work this way? It's really important that you start to gain an understanding of these techniques. Everything you're going to learn in this course is used in a forensics lab, although probably not the exact application that we're using for obvious reasons. We are not going to do TLC of LSD, for example, because we're not going to give you LSD in the lab. Instead, we're going to use things like caffeine and aspirin. But the basic principles are the same, even though we're not actually using drugs of abuse. So I hope you found this video helpful, and we look forward to working with you in the course, and welcome to the Forensic Chemistry Lab.